Hi, and welcome to how to assess your site and test your soils for bioretention facilities. I'm Maria Cahill, and if you've watched a couple of these videos, you know that I have been contracted by OSU Extension to help them with their LID Academy. But this particular presentation is good for anybody who's wondering where they can site their rain garden, stormwater plant, or a vegetated filter strip, those kinds of facilities that are going to infiltrate, and they want to place them safely. So let's get to that. I'm a songwriter, and so I wanted to do something fun, so I turned the criteria for siting a rain garden into a little Dr. Seuss-y poem. So you'll see a lot of things that rhyme here. So first thing we want to look at is horizontal separation, also known as setbacks. So how far does it need to be from all the different kinds of infrastructure that might be out there in the world? So the first part of our Dr. Seuss poem is, don't place your facility too close to a house or near any other footing that it might louse. Basically, we want to have it 10 foot from a building with a basement. It can be, and so we're showing two of those. It can be 5 feet from a property line, but that is basically based on the idea that you want to have it 10 feet from the building. So if we look at that 2-story condo building that's our neighboring building to our site, we're still, with where I've shown the rain garden there on the west side, we're still 10 feet from a building. And that's because my setback requirements are that we can't build buildings that are within 5 feet of our property line. Now, if your setback requirements in your zone are different, just make sure that it's 10 feet from your building and any other future building that might be allowed to be built on a neighboring property. And we can also see 2 places where the rain garden is actually bumping right up against a building. So one of them is where I have a 1-story outbuilding on pier footings. That is not a problem. That is considered a low impact development footing and is actually very beneficial to the watershed because it doesn't block groundwater flows. And we have a 1-story garage with a slab on grade. I could put my rain garden right up next to that, and I would feel very comfortable. Now, I would, in that case, want to put a vertical liner, probably 1.5 feet deep, right next to the building to make sure wherever the rain garden is butting up against it, and maybe a couple of feet on either side. But other than that, I would go ahead and put my rain garden in right next to a slab on grade. Since water flows twice as fast sideways as it does down, and the sound of water flowing into the basement is such an unwelcome sound. So this is the idea that without adequate horizontal separation, water can very easily flood our basement, and we want to make sure that we're far enough away. Water moves twice as fast in the sideways direction as it does down. That's counterintuitive to how we think of gravity, but that's how it is. And that varies with the soil. So clay soils can really wick out at a 2-to-1 slope. Faster draining soils might be a 1-to-1 slope, like sand. That might be a 1-to-1, or silt. Silt can drain very quickly also. Those might be more like a 1-to-1, but they're still going to go out. They're still going to drain out to the side somewhat. So 2-to-1 is a nice, safe bet. You don't want it too close to the top of a wall, especially when that wall is tall. So here we're showing an example of, well, we have a retaining wall here, and it's okay if we wanted to put the rain garden right up next to the bottom of the retaining wall, but we still want to be 10 feet from the top of the retaining wall. Water pressure builds up to push over the wall, and the result is very likely to appall. And of course, I'm talking about landslides. So we don't want our dirt moving somewhere we didn't intend it to go when we weren't watching. We also want to find out where pipes might run underground. So we want to be about 5 feet from those because there's a bunch of rock that is usually underneath those pipes. And it can be very easy for water to travel in those little ditches and undercut the pipes. So we just want to make sure that it's a good rule of thumb to be 5 feet from a water line or a gas line or a storm line or a sewer line or any of those kinds of underground pipes. And it's really easy to locate a private utility. You just call 811 and they will come out, and they'll the Oregon Utility Notification Center will come out and mark your ground with all of your private utilities. Very easy to do. Just give them a couple of days. And the lines overhead really ought to be found. So it's good when you're making a planting plan to think about, or a construction plan if you need to move materials around and there's going to be a dump truck that has to tip things. You want to make sure that you have a plan for not destroying the overhead lines or having a big tree grow into the overhead lines and then having it get chopped and topped by the city and becoming a hazard. And think about where other conflicts might be and give them some space. It's common courtesy. So just along a sidewalk, some people appreciate a bench sometimes, just a 1 to 3 foot type, narrow, flat area next to the sidewalk before you start sloping down. These facilities are only 6 to 12 inches deep anyway, usually. Sometimes they're deeper, and you don't want a big hole next to your sidewalk. So just sort of like a perception safety thing. And not under the existing tree drip lines. So here's an example where TriMet put in a project where there were existing oak trees, and they built a bioretention system, a little rain garden right in next to these trees. And actually the trees are receiving a lot more water than they used to. They established in this dry city planter regime, and now there's all this, the curbs have been cut and there's all this water coming in, and the trees are actually starting to decline. They're not doing well because they were used to one water regime and now they're getting another. We don't want to kill trees accidentally. It's okay to cut them down and make beautiful furniture out of them or windows or whatever it is we need. But if we intend to save a tree, let's actually save the tree. So the drip line here is what you're seeing is you can trace it up to the shape of the canopy, the outer edge of the canopy. That's actually where a lot of the feeder roots for the tree are going to grow, because there's lots of water there, and so there's going to be these tiny little feeder roots within the first foot of soil. They're going to want to grow along that drip line, and that's the area and a little bit beyond that you want to protect when you're saving trees. So let's not put our rain gardens under the existing tree lines. Not in sensitive areas, so not in wetlands, floodplains, riparian areas, and buffers. Habitat areas, there may be some upland areas which have some high value habitat. And then not within wellhead protection areas. So a wellhead protection area is usually a publicly owned piece of land that is protected for drawing groundwater, public water supplies from the groundwater. And so you would check with your jurisdiction to see if your project was in one of their wellhead protection areas, or within a horizontal distance of 2 times the depth of a nearby water well. So if your neighbor's drawing water up from the ground, you want to make sure that your facility is at least 2 times in the horizontal direction away from whatever the depth of their water well is. And you can search there's a lot of resources on our website, which I'm going to show you at the end of this slideshow, for how to figure out where you are, whether or not you have these sensitive areas on your property. And also not over septic systems, so not over the tanks, not over the drain fields, not over anything. Okay. An infiltration rain garden should never be on new fill. Compacted soil is likely to impact it still. So we have this, on the left we have our pre-developed site. On the right we have the post-developed site. So after development, it's the same site, but we cut a bunch of soil from the right-hand part of the site, and we filled it to make it flat, you know. So anywhere that we fill soil, we are compacting it, and that is basically turning soil into concrete, and it doesn't infiltrate very well. It actually responds a lot like concrete, and we only have infiltration in our cut areas, really. But even the cut areas probably got compacted during construction, so the picture on the right is really probably completely compacted, and it needs a couple of years to sort of work itself out. And with lawns, it might never really get that permeable again. But regardless, fill over 5 years might just be okay. In any case, test your soil's perk rate. So here's a picture of somebody who's dug a hole down to the bottom of where we think the rain garden is going to be, and we filled it with water to a depth of 6 to 12 inches, however deep we thought our ponding facility might be, and we're measuring how fast the water drops in that hole. So this is how we run a perk test. And there's information on the OSU Stormwater Solutions website on how to run a perk test. It's very easy. Basically, you do what I just described, and an easy way to rule of thumb way to test your soil is just to fill it 3 times and take the slowest infiltration rate as your design rate. Vertical separation. So a rain garden should never be placed down so low that the water in the bottom has nowhere to go. If bedrock is more than 2 feet or groundwater 3, a flooding problem may occur, you see. So water could possibly, if there's not at least 2 feet of soil that's got a good void ratio and is basically, not completely saturated, then water will flow into that soil and down the hill in whatever direction it's going to go. But if we have less than 2 feet, then we could possibly have water not getting into the soil as quickly as we thought we did, even though we tested the infiltration rate, and that means that water could back out of the system and cause flooding of some area that we weren't thinking of. So we have, example on the left where we've got bedrock at 24 inches. That's good. As long as it's 24 inches minimum to bedrock, that's good. On the right, we're showing an example of the groundwater table. That, we want to give ourselves a little factor of safety. So we add 12 inches to that depth that we want to see, because water, by capillary action, water can move from the groundwater, get sucked up into, about a foot of the depth of soil. So this rule of thumb on the right with the groundwater makes, we know for sure that we have 2 feet sort of like soil ready to receive the runoff and ready to move it away from our site and downhill through the voids in our soil. And then a tight soil layer that some call a fragipan might also be found beneath your pluie jardin. So pluie jardin may be French for rain garden. I really don't know. I don't know if the French have rain gardens, but I couldn't think of any other words that rhymed with fragipan, so I used pluie jardin. Fragipans may come in Oregon. They're very common as these impermeable ash layers that get compressed. Basically, a volcano blows, and there's soil all over the place, and a volcano blows, and it puts ash into the air, and that ash settles out, and it's pretty lightweight for a while, but over geologic periods of time, more soil and stuff gets deposited on top of that fragipan, and that ash layer, that fragipan, starts to get compacted, and it gets more and more and more dense, and it can actually block flows from passing through it. So if you want to, in some cases, it might make sense to punch through that fragipan and down into other soils. You want to do a little bit of investigation. But if you don't need to, by all means, if you have your 24 inches minimum to the fragipan, you're good to go. Don't worry about it. So after the perk test, dig a few feet deeper to see that there's enough soil depth for the runoff to flee. Using this guidance and your common sense, your facility is sure to work without lament. Okay, So here's a little blip on infiltration testing. I'm not going to go into that. I'm going to show you how to find information for yourself. So if you Google OSU Stormwater Solutions, it will take you to the home page. So it looks like this, Stormwater Solutions. And if we go over here to the left, which says Steps to Take, gather data and plan your site. And there's a fact sheet on infiltration testing, which is super handy. And so that'll teach you how to do an infiltration, a whole bunch of different kinds of infiltration tests for different kinds of facilities. The simple one that I described is good enough if you want to do that. That has been used by professionals in many, many places, and it works just fine. But what else? The other thing that I wanted to show you was under decision trees. So we have a super cool tool that's still evolving, but I can still show this to you right now. So it helps you choose between all the different rain gardens. There's 6 different kinds of rain garden configurations that we have, and this will lead you, if you answer all of the questions in a particular way, it'll lead you to a very simple, very easy to build, very easy to maintain infiltration rain garden. And if you answer other ways, it'll take you on the other end of the spectrum to a very expensive to build, very expensive to maintain lined filtration facility. And there's designs that are in between those two choices. But this is one way to figure out whether or not you're meeting the siting criteria for rain gardens. So you look here and you say, rain garden will be located in a floodplain or over septic systems. And if you say yes, well, remember I told you you're not supposed to put a rain garden in those areas? You're not supposed to put an infiltration rain garden in those areas. So you could possibly put a lined filtration rain garden in that area. I personally would, and here's all the information that you would need to do that. I personally would be a lot more interested in seeing you do other practices before you did a lined filtration rain garden. But lined filtration rain gardens may be required by your jurisdiction, and you just have to do them. And the reason that I personally would like to see that is because it doesn't provide regional water quality treatment. It treats the water on site, but as long as you're sending volumes off site, and here's the detail, then it doesn't work as well. But anyway, if you go back and you answered, no, I'm not going to put my rain garden in any of those places, that would be silly. Then it'll go on and it'll ask you a lot of the other criteria of things that we talked about. And down below is information on how to answer those questions. And like I said, this is in flux. This is going to be even easier to use. We're going to add a navigator to this. But here it is. And you know how to get to it now. So have fun siting your infiltration bioretention facilities.